Hi friends, good afternoon. Today we are focusing on another section of vector analysis, that is unit vector matrix, right? We already seen different kind of unit vectors in different coordinate system, right? For example, in Cartesian coordinate system, what we seen? In Cartesian coordinate system, we seen unit vector I cap, j cap, k cap, alright? Or we can write x cap, y cap, z cap. In plane polar coordinate system, we require two coordinate, that is r cap, theta cap, right? Now in cylindrical coordinate system, which are the unit vectors we seen? R cap required and phi cap required and z cap required, right? And in spherical polar coordinate system, r cap, theta cap, phi cap, right? So different unit vectors we seen, right? So I cap, j cap, k cap. Sometimes the notation, different books using different notation, right? For example, this r cap, sometime theta cap instead of theta cap, phi cap, but the meaning is same, right? But the value selection is very important, right? In plane polar coordinate system, theta is varying from 0 to 2 pi, because plane polar coordinate, one complete circle in a plane forms 0 to 2 pi. But here r cap, here phi cap, z cap, this is 0 to 2 pi. This is 0 to pi, right? This is 0 to 2 pi. We already discussed the range of different parameters, and also sometimes some books are representing in spherical, cylindrical polar coordinate r cap as rho cap. Okay, so the meaning is same, right? So different notation may use, but you should be aware about the range of parameters, what actually that parameter represent, right? Notation may be different, alright. So different unit vectors we seen. Now today we focus on how to create a relation between this Cartesian coordinate, Cartesian unit vector, and suppose in plane polar coordinate r cap, theta cap, right? How we connecting these two? So one coordinate system to another coordinate system changing is possible by finding a relation between Cartesian coordinates and different other coordinate system, right? That relation we must require, right? So here we focus on that. So here you see r cap, theta cap, right? So plane polar coordinate system, right? How we represent a position vector? R is equal to cos theta I cap plus, right? R dash is equal to R cos theta I cap plus R sin theta j cap, right? How plane polar coordinate? We already seen plane polar coordinate system. So if you have a vector R, so the x coordinate should be R cos theta and y coordinate should be R sin theta. We know that, right? So generally we represent R dash is equal to xi cap plus y j cap, right? Position vector generally we represent what? Xi cap plus y j cap. Then x is equal to R cos theta, y is equal to R sin theta. Now I require this R dash, right, is this. Now I require a connection between this r cap, theta cap with I cap and j cap, alright. Now let me think in one way. What is the length element we studied in plane polar coordinate system? That also we studied. What is length element is dr dash is equal to, what we studied? In the direction of r, what is that? Dr r cap, right? And in the direction of theta, what is the length element? R d theta, theta cap. Alright, this length element we studied in different coordinate system. We studied length element, areal element, volume element in different coordinate system, right? So here, what is this dr dash by dr? From this dr dash by dr, you see what you get? R cap, right? Because with respect to dr, I am differentiating this r dash. Then with respect to theta coming, that this part will be 0, right? Here this with respect to dr, right? Here r cap only the variation, other compound is varying with theta. Now to find theta cap, what I do? Then I have to bring this r here, then 1 by r dr dash by d theta is equal to theta cap, right? Now how dr dash by dr you calculate? From this very simple. How dr dash by dr? So you can find dr dash by dr, that is r cap. That is r cap is equal to dr dash by dr. Dr dash by dr, that is equal to, when you differentiate with respect to r, this is equal to r on doing 1, cos theta is a constant. Then cos theta I cap plus sin theta j cap, right? Now next is theta cap. What is theta cap? Theta cap is equal to 1 by r, right? Dr dash by d theta, I am differentiating this with respect to theta, dr dash by d theta. Then what come? R I am taking out, cos theta on doing, minus sin theta I cap, again r is taking out, then sin theta on doing, cos theta j cap, alright. Now this r cancel. Now r cap you got in terms of I cap and j cap, theta cap you got in terms of I cap and j cap. Let me write this as r cap is equal to cos theta I cap plus sin theta j cap, alright. Now what is theta cap? Minus sin theta I cap plus cos theta j cap, alright. Now I can represent this in the matrix form. R cap theta cap is equal to, what is this matrix? Cos theta sin theta minus sin theta, then cos theta, matrix into, right, look here, I cap j cap, right. So now you got the connection between I cap j cap and r cap theta cap. This is in plane polar coordinate system, right? So in plane polar coordinate system, we can represent the connection between I cap and j cap and r cap and theta cap. Now suppose in any situation you want to find I cap and j cap in terms of r cap and theta cap. What we do? There is a basic method using. So how we do that? So you can write I cap and j cap. Then what you have to take? That x is equal to A inverse B formula. That means suppose this I am considering as x matrix, then its inverse. What is the method to find inverse of a 2 by 2 matrix? You know, cross this element, that is cos theta, change the sign of diagonal element, that is this become minus sin theta, this become sin theta, right, into, now you can write r cap theta cap here, right. So the converse you can write by taking inverse of this matrix, right, that also possible, alright. Now this is regarding the plane polar to Cartesian. Plane polar you are converting into Cartesian, right. Now let us come to how cylindrical coordinate we can represent in terms of I cap, j cap, k cap, right, alright. See, that is given. How we reach to this expression? Let us see. See here, what is the position vector in cylindrical coordinate? R dash is equal to xi cap plus yj cap plus z k cap. Now in cylindrical coordinate, what we studied, x is equal to r cos theta, right? Y is equal to r sin theta and z is equal to z only, right? So now what is the length element we studied in cylindrical coordinate? That is dr dash is equal to, right, in the direction of r, dr increasing, dr r cap, in the direction of theta, r d theta, theta cap, and in the direction of z, dz, z cap. This is the length element we studied, right? In cylindrical coordinate we used r d phi phi cap. That's not an issue. Here theta is represented in such a way getting the same meaning of phi only, right? The theta range is 0 to 2 pi, alright? Don't confuse with it, right? So dr r cap plus r d theta theta cap plus dz z cap. Now what is from this dr dash by dr, what? You can find a dr dash by dr. See this dr come here, then this get r cap, right? This is variable is theta, then this part is 0, this is variable is z, that part is 0, right? Now here this r d theta come here, what you get, a 1 by r, this r coming here, d theta come here, then dr dash by d theta, then theta cap only, this term with respect to d theta I am differentiating, then here d theta is the variable, then dr part is 0, dz part is 0, then this is equal to theta cap, alright. Now dz, regarding dz with respect to dr dash I am differentiating with respect to dz, then dr dash by dz, what is that? That is our z cap, right? Then we defined 3 unit vectors, r cap, theta cap, z cap. Now see, look here, here mentioned this r d theta phi cap, this unit is phi cap they mentioned, alright. So strictly think about here I mentioned theta cap, alright. So you can measure here theta cap, here instead of r cap they represented rho cap, but it is giving the same meaning, alright. Any notation you can use, alright, alright. Now let us come to how the matrix formation we do. By simply differentiating we can do, right? Look here, dr dash by first part is r cap is equal to dr dash by dr. Dr dash by dr I found from here. What is dr dash by dr? With respect to r doing 1, what is remaining? Cos theta. Cos theta, right, I cap, alright, plus with respect to r dr dash by dr, here r1 doing 1, remaining sin theta, right, j cap. I'm sorry, here one j cap, alright. And with respect to z, dr dash by, right, look here, dr dash by dr I am doing here no r component, then this part is 0, then 0 k cap, right. Now similarly I can do theta cap, right. What is theta cap? Theta cap is equal to this 1 by r, right, dr dash by d theta. If I do dr dash by d theta, right, r you can take out. So cos theta differential is minus sin theta, right, I cap. Again here r I am taking out, sin theta on doing cos theta, j cap, right. With respect to theta, z on doing again 0, 0 k cap, alright. Now again I am writing z cap. right, z cap, what is that? dr dash by dz. dr dash by dz do this 0 because here no z variable, here only 1, right. Then 0 I cap plus 0 j cap plus here 1 k cap. Now this you can write as a matrix. Look here, r cap, here we mentioned here r cap only, here row only mentioned, here I am mentioning r cap, here I am mentioning theta cap, here I am mentioning z cap. Now check the coefficient, cos theta sin theta 0, cos theta sin theta 0. Here this r remaining all cancel. Here minus sin theta cos theta 0, minus sin theta cos theta 0. Alright, and think about this. Here first coordinate, first coefficient of I cap is 0, 0, here also 0, here 1, right. Then what is common? I cap here, j cap here, and k cap here. So I cap, j cap, k cap. As in the same way how we done the plane polar coordinate system, here we represented as a matrix. Alright. So this is the matrix representation of connection between cylindrical coordinate and Cartesian coordinate. Alright. Alright. Now finally we can represent spherical polar coordinate. How spherical polar coordinates are related to Cartesian coordinates, right? Alright. See here, look here, in spherical polar coordinate, how we represent x, y, z, we already studied in our spherical polar coordinate system classes. We derived x, y, z representation, right, in terms of spherical polar coordinates, r theta phi. What we studied? R sin theta cos phi, right. Here what? R sin theta sin phi, alright. Here z is equal to r cos theta. This only we studied, right. Now how generally we represent position vector? R dash is equal to xi cap plus yj cap plus z k cap, alright. Now dr dash, length element, right. So this r dash I can represent first in terms of this x is equal to r sin theta cos phi I cap plus, right, r sin theta sin phi, r sin theta sin phi j cap plus, right, r cos theta k cap, r cos theta k cap. Alright. Now look here, what is dr dash? Dr dash, the length element in spherical polar coordinate system also we studied. What is that? In the direction of r, increment is dr r cap. In the direction of theta, r d theta theta cap. In the direction of phi, what is the length element? R sin theta d phi phi cap. Alright. Now from this it is very clear what is r cap. R cap is equal to dr dash by dr. With respect to dr I am differentiating, this part 0, this part is 0. Why? Because here variable is d theta, here variable is d phi. Alright. Now what is similarly, what is theta cap? Then theta cap you should bring this r d theta, right, or differentiate with respect to d theta. Alright, that means 1 by r dr dash by d theta. Then what about phi cap? Phi cap is equal to this r sin theta d phi, right, with respect to d phi you have to differentiate. Then r sin theta d phi come here. Then 1 by r sin theta, right, here dr dash is there, dr dash by d phi. Now it is very simple, just a differentiation only. What is r cap? R cap means you differentiate with respect to r. That means with respect to r you do this part is 1, this part is 1, this part is 1. What is remaining? sin theta cos phi I cap plus sin theta sin phi j cap plus cos theta k cap. Then r cap we got. Now regarding theta cap, what is theta cap? Theta cap is equal to 1 by r of, right, dr dash by d theta. Then with respect to theta, sin theta doing cos theta only. Then r remaining we can take out because it is constant. Then r sin theta become cos theta. R cos theta cos phi, right, cos phi I cap. Again this sin theta on doing again cos theta, right. Then r cos theta sin phi, right, sin phi j cap. With respect to theta you doing r into minus sin theta, right, cos theta on doing minus sin theta. Then r into minus sin theta k cap, right. Now you can cancel this r. Now theta cap also we got. Now what is finally remaining? Phi cap. Phi cap is equal to, then 1 by r sin theta I can keep out. Okay. Now dr dash by d phi with respect to phi you are doing, then this become minus sin phi. Cos phi on doing r sin theta is no change. Then this cos phi become minus sin phi I cap, right, plus now here also this sin phi become cos phi, right. Then r sin theta sin phi become cos phi, right. And by doing with respect to phi doing here no phi variable, then this part will be 0 k cap, right. Now this r sin theta cancel. Now you can easily write in matrix form r cap theta cap phi cap, r cap theta cap phi cap. What is the coefficient of this? First sin theta cos phi, sin theta cos phi, sin theta sin phi, sin theta sin phi, cos theta, right. Then r cap coefficient I written. Now theta cap coefficient vector is cos theta cos phi, cos theta cos phi, cos theta sin phi, cos theta sin phi, minus sin theta, right. Now here phi cap coefficient, here minus sin phi, here cos phi, here 0, 0, right. So in spherical polar coordinate, and then here I cap common here, j cap common here, k cap common, then into I cap, j cap, k cap. So in spherical polar coordinate, these are the connection matrix form between spherical polar coordinate and Cartesian coordinates. Alright. So this unit vector matrix representation is very important when we do rotational matrix, rotation of frames and everything in classical dynamics, quantum mechanics and all, right. Alright, we do some problem at the end of this chapter, right. Okay, thank you.